am Radha Guha, and I have started this lecture series. And my first subject is computer organization and architecture. So, in this subject, I am going to start. This is the first lecture on this subject. Sorry, this is the first lecture on this subject. So, first of all, I am going to cover what is in a computer. What is a computer that everybody knows because everybody is using computer, very powerful computer. You all have smartphone. Not only engineering students, everybody uses a computer for surfing the internet or for uh, e-commerce, etc. So I am going to cover first of all what is inside a computer. So there are many components are there. Those are called hardware components, and those components are interconnected, and they work in coordination with each other. They are made to work in such a way that the computer executes a program. A program is again written by a programmer, and that is fed to the computer, and these hardware components will work in coordination to execute the instruction given by a programmer. So we are going to see what are the components are there, how they are interconnected, and how fast the computer can work, what is the power consumption of a computer, how it is measured, okay, how much a computer cost, etc., etc. We are going to start with this topic because we are going to cover start from the history of the digital computer. The history of computer is only around 70 years old. We are started using this modern computer from 1950s onward. So we are going to cover some history also, so that you are more become more interested in this topic, and you can figure out the components and how they are interconnected. Okay, so the modern computer architecture was proposed in 1965 by one scientist called John von Neumann, and since then we are following that architecture. The architecture means the component interconnection, how the components are organized, and how the program is supposed to execute. So that is what we are going to see. So the next is, as I said, this computer is a very complex machine, and it can be studied from many different perspective. So, first of all, it is the technology, how a computer is built, what kind of material. Okay, so we are going to see what is the technology and how it has evolved from 1950s till now. That is the main thing you need to know. And then what kind of applications can run. The programmers are running many different application, scientific computation, surfing, e-commerce, etc. Many different kind of applications are there. But all the applications need to do some basic things like interaction and coordination of the components. So those common things are grouped together, and it is called the operating system of a computer. So that is also one way of studying a computer. Then we are going to see how the computer's performance is measured. Performance mainly is measured by how fast is a computer. Not only how fast, there are other parameters also, how small a computer is, and then what is the cost of a computer. Cheaper computer is better. And then what is the power consumption of a computer. The small less power consumption is better, etc. So we are going to see how they are measured, also. Then another way of studying a computer is studying, knowing about compilers. As I told you, high level programming languages are written by the programmer, but the machine only understands zeros and ones. But to instruct a computer by a series of zeros and ones will be very complicated, because nowadays we are doing a lot of things. Okay, if it is only one operation, it's okay, I can remember the sequence of zeros and ones. But a computer is going to perform a lot of things. So a high level language, programming language was designed, which is much more user friendly. But those high level language programs, they are actually converted to low level machine language, and that is the job of the compiler. So computer can be studied from that perspective also. Then another thing is interface design, which is called ISA. Interface design means there are many different computer vendors are there. So particular vendors, they say that computer can operate these many instruction. These are the type of instruction the computer can execute, and it varies from one vendor to another vendor. Also, it varies a little bit from one model to the next model. More modern computer has more sophisticated instruction set. So it can also be studied from interface design, also instruction set architecture design. And there are so many programming languages have been designed. Some are for scientific computations, some are for web serving, some are for commercial, some are for this internet surfing, where there will be a lot of users accessing the computer, same server computer at the same time. So there, for that there are many programming languages are there. You must have known the name of C program, C++, Java, Prolog, Python, etc. And then parallelism. So when you have a machine, it executes the program. Now, if you increase the number of hardware components, there may be that it can execute more instruction at a time. So, if that is possible, that is called parallelism. So, we are going to see how parallelism is achieved, and is it only the hardware component that matters, or it also depends on software, um, uh, which the computer is going to execute. So computer is a very complicated, complex machine. It is the greatest invention of the 20th century, and we are studying this computer, so it can be studied from many different perspectives. Okay, so this is a core course for BTech and MTech level courses for any engineering student, mainly computer science engineering, electronics, electrical and communication system engineering. And usually we follow some standard good textbook, and William Stalling is the author of this book, Computer Organization and Architecture. It has a website also, which with more these lecture slides plus students resources like exercises and their answers, etc. So you can refer there also. Okay, so first of all, we are going to see the history of the computer, how the computer evolved from the very starting. Okay, so we are going to see that. So I told you before that this modern computer, uh, we are using modern computer from 1950s, and this modern computer was possible because of the invention of an device which is called transistor. Transistor is a three-gate device which conducts electricity and which can be controlled also. The same functionality device was there before the invention of the transistor, and it used to be called vacuum tube. In the left hand side image is showing vacuum tube, and the right hand side image is showing the transistor. So you can see the vacuum tube was much bigger. In comparison, transistors are much smaller, and the vacuum tube was enclosed with a glass enclosure, so it is breakable, easily breakable, whereas transistor is not breakable. And vacuum tube consumed a lot of electricity, whereas transistor consumes less electricity. So in comparison to vacuum tube, transistor is much better. Okay, so the after the invention of this transistor, which happened in 1947 by three scientists, their name is William Shockley, John Bardeen, and Walter Burton. They were working in Bell laboratories in USA, and they invented this device. And the technology is the semiconductor technology. They used a semiconductor material um, to create a three-gate device where electricity can be controlled between the two gates by the help of a third control gate. Okay, and then this device was so much better than the previous technology that it replaced the vacuum tube altogether. And the demand for a design of a computer was there all the time before even vacuum tube. I'm not going to go to the history very too much back in the history, in the timeline. But need of a computer, why we need a computer, if a machine computes, then it takes a less time, so doesn't depend. Human to human expertise is needed for computing something, but if a machine can compute it, it can compute much faster than a human being. That's why the computer was designed before also. And now, after the transistor came after vacuum tube, that path of computer design became much more successful. Okay, so the first computer that was built using vacuum tube, its name was ENIAC. ENIAC stands for Electronic Numerical Integrator and Computer. And it was designed by two people, professor and his student Eckhart and Mauchly, in University of Pennsylvania in 1940s 1943. They started it. If you know that this is the time for World War Second World War, and US Army, they needed to compute the trajectory of the weapons, because manual computation takes much longer time. So if there could be a machine which can do these things automatically, it will take less time. That's why they gave this project to these two people, and then they started this project, and they finished the design of the computer in 1946, and they used vacuum tube, the prevalent technology at that time. And this computer was used till 1955 because 1947 transistor was invented, and using transistor computer was built. Now in the next slide it will tell you how what was the specification of this ENIAC computer. So this ENIAC computer use 18,000 vacuum tube. So each vacuum tube is big. So the 18,000 vacuum tube machine built with 18,000 vacuum tube, it was very huge. How much huge? It was weighing 30 tons, and it was occupying 15,000 square feet of floor space. It was consuming 140 kilowatt of power consumption, and it can only do 5,000 additions per second. Nowadays, the smartphones can do much more computation per second. Okay, so this was that time only, 1943 46. This was the computer. So if you have to know about the history of computer, you must know the name of the first computer ENIAC built with the vacuum tube, and what was its specification. Then another computer built was this one, DISEC, DYSEAC. It was also very heavy, but jokingly it was called a mobile computer because it was placed in the truck, and it can go from one place to another place. So that was the scenario of computing at that time. Then came transistor. So here in this slide, it is showing three physicists, scientists of Bell Laboratory. They invented this transistor, and they are showing that how strong is the transistor is. And this invention of transistor is so much better than the vacuum tube that they were given Nobel Prize. They got the Nobel Prize in 1950s. They got the Nobel Prize for it. So here you can see that comparison of vacuum tube versus transistor. So this is showing vacuum tube, big size. Now here it is showing the discrete transistor. They are small. These transistors have their own casing, each individual transistor. So it is called discrete transistor. Now the technology changed. Okay, from individual transistor to a lot of transistor in the same semiconductor chip, and it is called integrated circuit. And this was invented in 1956 sometime, that time. And since that time, even the construction of IC chip is improving. Number of transistor that can be embedded in the same chip is increasing, and the size of the chip is also increasing. So a lot of transistor could be embedded in the same chip. So the first it started with small scale integration where only few thousand transistors in one chip. Then it improved to medium size integration where tens of thousands, hundred of thousands of transistor in one chip. Then it changed to VLSI, very large scale integration, millions of transistor, ultra large scale, billions of transistor in the same chip. Okay, and how is that possible? It is possible because the size of individual transistor decreased. Okay, I am going to show another slide how the size of the transistor is measured. It is measured in nanometer. That slide is coming next. I'm going to show that to you. So that is the reason individual transistor size decreased, and also the chip size. This is called a die or a chip where a lot of transistors are embedded. It is also increased a little bit. So as a result, the transistor density in the chip increased. Okay, so the what is modern electronics? Modern electronics era started with transistor and then the integrated circuit chip. Okay, so what is a usual size of a IC chip? It is 100 square millimeter. Not very big, 100 square millimeter. You know what is a millimeter? It is 1000 of a meter. Okay, so this is the technology, transistor, IC chip, which are used for building a computer. And here it is showing a time scale how technology changed. This is called electronics milestone. The history is showing from 1874 here till 1995. You can read all of them. Let me highlight only few of them. Here it is showing 1947 invention of transistor. Then 1952 was the commercial production of the transistor, and then 1956 they get a Nobel Prize because these transistors are so much better than vacuum tube. Then 1958 is the invention of IC chip, integrated circuit chip. 1960 it was done by Fairchild Semiconductor Company. And who is the inventor? Jack Kilby, Noyce, and Moore, Gordon Moore. Okay, you must know their name. Gordon Moore is famous for his own law also. We are going to see that. Then commercial production of chip started in 1961, and since then it kept on improving. So these transistors inside the chip are connected in a circuit so that it can perform a particular kind of computation. You know what are the computation a computer performs: addition, subtraction, multiplication, division, and then some logical operation, and or greater than, etc., etc. So this same semiconductor technology is also used um, for some other purpose, which is called a memory chip. When you are processing something, you need data, and data is zeros and ones. So these zeros and ones are saved in this semiconductor chip, which is called memory chip, and that technology also improved. Uh, so in 1984, it was only megabit memory chip. It can store 1 million bits. One bit is either a zero or a one. And in 1995, it became gigabit, and the scale continues. Now we are in 2024. Processor technology and memory technology both have continuously improved. Okay, so with the help of this transistor and IC chip, every electronic devices, so many electronic devices came up. For everything there is electronics, not only for computer. All electronic devices are made with this IC chips. Okay, and so the production of IC chip nowadays is 10 to the power 18 transistors, and which is a very big number. Just to compare it, get some idea what is 10 to the power 18. You must know that number of cells in a human body is 10 to the power 14, much less than number of transistor. Number of seconds elapsed since Big Bang. Big Bang is the time where our universe was created or manifested. It is only 10 to the power 17 seconds, still less than number of transistor produced in recent year. And number of ants in the whole entire world is roughly 50 transistor for every ant in the world. So you can see the production of transistors are so high, so much high, because every electronic devices are using transistors and IC chips. So with this IC technology, the computer is built. Now the main component in a computer is called a microprocessor. So microprocessor, which is also called CPU, central processing unit, and there is a law, I told you, Gordon Moore, who invented, one of the three scientists who invented the integrated circuit chip. He's observed that from 1958 to 1965, number of transistor in a chip is doubling every 2 years, and he predicted that this trend will continue forever. And his prediction, he was such a good visionary that his prediction came true for a very very long time in 2020s also. So you can see, following Gordon Moore's law, 2000 300 in 1971 it was, wait a minute, in 1971, it was 2003 one transistor working at 1 million hertz clock speed. We are going to see what is this clock speed. This clock speed actually tells you how fast is a computer. So that time in 1971, clock speed was only in megahertz. Number of transistors is only 2300 transistor. So it is using small scale integration SSI chip. Then it improved to 16 million transistor. Then 42 million transistor working with 2 gigahertz clock speed. This happened in 2001. Then 55 million transistor um, uh, working at 3 gigahertz, and it is also telling the transistor size 130 nanometer technology, and the die size it is telling 250 millimeter square die in 2004, and it kept on increasing. Then it came 1.8 billion transistor used in Itanium 2 computer in 2008. So, processor technology, it is also given in terms of transistor size. So it is showing, this slide is showing how the transistor size became smaller and smaller. In 1997, it was 250 nanometer. In 2002, it became 130 nanometer. It kept on decreasing. In 2011, it is 22 nanometer. Okay, so transistor density is increasing 35% per year, and the die size is increasing 20% per year. Okay, why the transistor density increasing? Because individual transistor size shrank over the years, and this is a great technology improvement.